Hey, and welcome to Science Streams. Today we are going to be talking about lipids. This is in a series of videos for biology students, high school through beginning college bio. And if this is your first video, I encourage you to go back and watch some of the previous videos. We went over some of the other macromolecules. We're going through those macromolecules right now, and we're on to lipids. So I hope that you can stick with us, watch these videos, and hope you get something out of it. And this is being streamed initially on Twitch and then sent over and exported to our channel on Science Streams on YouTube. So depending on where you're watching this, thank you. I appreciate you being here and your support. So let's get going. Lipids. This is going to be probably a slightly longer video than some of the other ones, which really isn't a problem. But there's a lot more to talk about with lipids. They're kind of an interesting macromolecule in that they are different than the other ones we've talked about, in that carbohydrates, nucleic acids. So those are going to be hydrophilic. They like water, so they'll dissolve in water. That's great for biological substances, right? Because it's mainly water-based. We want them to be able to dissolve in water. Lipids are kind of classified as a group because they are hydrophobic, so they will not dissolve in water. Right, and so this is why the oils and fats you're familiar with do not dissolve in water. And unlike the other macromolecules, there are not monomers that come together to make polymers. Okay, so like proteins that have amino acids that come together to make the extended structure of proteins, or the monosaccharides that come together to make polysaccharides. This case, lipids, no, they're different. So it's an amalgamation of a bunch of other stuff that just doesn't fit with those other macromolecules. And so generally it's broken down into either 3 or 4 bigger groups of lipids: fats, steroids, and phospholipids. And we're going to go through each one of those groups in some detail, and just giving you the basics. I'm not going to bog you down in a really long video about these, but give you it succinctly and simply for what you need to know. So fats. Chemically, they're composed of a glycerol. You can see that picture of a glycerol right over here. And when we talk about fats, they will have a fatty acid chain coming off of it, and you get 3 fatty acid chains. You're going to get a triglyceride. So you have the glycerol, 3 fatty acid chains, triglyceride, tri-3. And you can see a picture of that here. And you can see how you have the structure of that glycerol here, all right, combining with that fatty acid chain. And this is important to note in this. So if you direct your attention over to our screen here, all right, if we have our carbon for our glycerol, right, and remember carbons are really important in biology, right, and in this glycerol we have this hydroxyl group coming off of it, this OH group, for each of these. And originally this fatty acid will come in, and on the end of that fatty acid, okay, we'll have this carboxyl group on this fatty acid, right? And by the way, this is much more for higher level biology, like advanced biology in high school or college level. High school, just standard bio, you won't need to know this, but hey, it doesn't hurt to get ahead of yourself here. Okay, so at the end of this fatty acid chain, right? Right? It's going to look like this, right? And this our chain comes off of here, right? It keeps repeating after here. And guess what we're going to have happen, right? We're going to have this combine here. And you can guess, if you watch these previous videos, dehydration synthesis. So I said before, that's really important. And it is. All right. Whenever we have these coming together to make a larger structure, often it's going to be this dehydration synthesis happening. Okay. So this is how your triglycerides are made. Right. We have this fatty acid. This chain is going to combine with your glycerol. In this case, we have 3, and this is why we generally have this triglyceride. And the next piece to this is knowing, what's going to come of this, right? We have this being made, right? But we have 2 kinds of fatty acids. Okay, we have saturated and unsaturated fatty acids, and this is simply, if it's saturated, it is all single bonds. Now, remember, each of these, when I draw this structure here, and this is saturated, right? This is all carbons with hydrogens coming off of it, right? This is just simply how we're just going to draw it in a simplified structure. All right, if we have double bonds, even one, right, coming through here, then we end up having it be unsaturated. All right, that's being unsaturated. Okay, and within this double bond, I'm going to go into one more piece of chemistry here, because this is important for those of you in higher level biology. We have this idea of cis and trans. So we have this double bond, right here. All right, and we can classify how that double bond looks as to either cis or trans in its structure. And this is how we come up with the unhealthy trans fats. Okay, so, and we're going to use this symbolism for our R group. All right, to do this. Now, if it's on the same side, this, all right, these groups, then we're going to call this cis. All right, cis fat versus a trans fat, right? We're going to have a differing structure. And I'm trying to write neat, but also go fairly quickly through this video for you. All right, now this is a trans fat, really. Okay, that's generally seen as unhealthy. And this goes back to, remember, how this unsaturated fat ends up being described chemically. Okay, so another interesting thing you should know when looking at these, especially these saturated and unsaturated, our saturated fats tend to be closer together and are more generally found in animal fats. Animal fats, as you might be aware of, you go into your kitchen, you look at like the fat attached to your piece of beef or pork, right? It's going to be solid at room temperature. Whereas your unsaturated fats, because of the branching, is not going to be as solid at room temperature. That's why your olive oil, your corn oil, your vegetable oils are still liquids when they're sitting in your pantry or in your fridge. Okay, so keep that in mind also when it comes to saturated, unsaturated. It's a good way to identify which kind of fat you have. And often in biology, when we're asked to be problem solvers, right, we have to be able to describe why something exists the way it does. So this is a good distinction between these two, right? Our saturated fats are generally solid at room temperature, whereas these are more likely to be liquids, right? Because of that kinking, all right, in the structure. So that's a lot for these, but this is all you need to know for your basic bio for fats. Okay, that's a big part of lipids. The next really big part is knowing the structure of what we have called the phospholipids. And you will get sick and tired of hearing about the phospholipid bilayer. Okay, the phospholipid bilayer, this makes up the membranes of all cells and also the membranes within cells. And when we look at this bilayer, we want to be able to describe how this bilayer looks based on its structure. So, as always, form equals function. And we see here in the phospholipid, similar to what we had before, we have a glycerol up here at the top, just like we had previously in our fatty acid, or so our triglyceride. But we have this phosphate group attached to that third carbon. And that phosphate group, if you notice, is going to give it a charge. Now, we talked about before how the functional groups we learned about in a previous video. Those functional groups can impart uses and changes in function for molecules. And this time we attach that phosphate to that glycerol. It's going to then make it polar, so that end suddenly becomes hydrophilic, right? It now likes to be near water, whereas these saturated and unsaturated fatty acids down here, these chains of carbohydrates, these make it want to not like water. These become hydrophobic. So all of a sudden we have one end that likes to be near water, one end that doesn't like to be near water. And so this is what enables it to form and have that function of a cell membrane. So when you put a bunch of these in water, they will arrange themselves, right, such that we have those hydrophilic heads, right, will be on one side, and all of these other ones will be on the other, and we'll have those tails will meet up in the middle. And you will see this type of diagram over and over again as we learn about cells, and it's very important that you kind of understand why this happens. Because it's important for us to know this. So we have this water out here, we got water out here maybe, and those heads, which are hydrophilic, want to be near it. The tails do not. So when you're thinking about cell membranes, always remember this phospholipid is involved, and it's because of those functional groups that in their properties that gives it that form and therefore that function. Lastly, we're going to talk very briefly about steroids. I found that most teachers spend very little time in curriculum, spend very little time on steroids. Yours might be different, but it's mainly just given as another example of something that is, a lipid, but right, and it has its formative function and its purposes. So cholesterol in an example, and that's found in your phospholipid bilayer. Often it's found embedded in here, and guess what? It's generally hydrophobic, and so it'll be found in the interior. for that cholesterol. If there happens to be a functional group on it that is hydrophilic, of course, it'll be exposed to the water side. Basically, there are 4 fused rings in these cholesterols and steroids, and that's the structure. So I'm not going to get too much into it, but it is considered a lipid. Like I said, lipids are kind of just all grouped in that they are, in general, hydrophobic. They do not mix well with water, or if they have a large section that does not mix well with water. So, and that is generally all you need to know about your lipids. Thanks for watching. Please watch the other videos in the series. We got more coming up. We talk about proteins as well as nucleic acids soon. Thanks for checking out this channel, whether on Twitch or on YouTube. And keep doing good work, study hard, and later.